Hi, it's Kevin Lobates here, and today's video is a quick and rather simple tutorial about how you can use resources on the web in order to investigate smart contracts. And the smart contracts I'm going to be looking at are NFT smart contracts, but this kind of works for other contracts too. It's just the initial finding the contract that is different. Anyway, I'll just dive straight in. Imagine that there's a token on OpenSea that you are particularly interested in, and you want to understand a bit more as to what is going on under the hood. So I'm using my Authorverse contract as an example here because it's something that I'm familiar with, and full disclosure, it is also an opportunity for me to advertise this NFT project. But anyway, you're on OpenSea, there's a collection you're interested in, it has some tokens. What you can do is you can go and click on one of the tokens, and you get a whole bunch of stuff about that token, its collection, the name of the token, an image to do with it, some stuff about its traits. And then if you scroll all the way down to here, there's a details option. And when you click on that and open it up, the thing we're interested in is this contract address part. And conveniently, you can just click on it and you get taken to Etherscan. Now, Etherscan is a website and a company who specialize in scanning the Ethereum blockchain and recording all the information on it in databases so that that can be quickly retrieved and people are presented with a nice front end to be able to explore what's on the Ethereum blockchain without having to use a command line interface or run their own Ethereum node. So that's very handy, and it's available for free. I imagine they have some paid plan or something, but for the average user, it's just an information site. Now, if we go and look a little bit further down, we can scroll past how much money the contract has, information about when it was created and who by, and the contract address. But the thing that we're particularly interested in here is this third option, contract. And one of the green flags for this contract is that the source code has been, in quotes, verified on Etherscan. Now, that doesn't mean that somebody has gone through the contract and checked that there's nothing malicious in it. What it means is simply the source code that was compiled to make the NFT contract and deploy it on the Ethereum blockchain has been made public and is visible on the Etherscan site. So I'll click on that, and indeed here it is. There's a whole load of code here that shows you exactly what the NFT contract we're looking at does. Now, this is an awful lot of stuff to go and dig through, and even though I'm not particularly fluent, but reasonably fluent in Solidity, I don't start by looking at all the individual lines of code. It's just too much. The first thing I do is I go and look at these read contract and write contract buttons. So when we click on read contract, what Etherscan does, and it's very handy, is it shows us all the information that we can read from the NFT contract. That means that the contract contains a bunch of what are called view functions, and you can call them and they just give you information back. And the neat thing about view functions is that there's no cost associated with calling them. You can get information off the blockchain for free. It's only writing to the blockchain that costs money. So here we already have some indications as to what is going on with this contract. There's a bunch of constants that we can get the values of. So for example, we can see what revealed tokens limit is. It looks like there is an upper cap of 10,000 revealed tokens for the Authorverse contract. We can look at how much it costs to do something called flip realm. And again, it's this number here. Now, that may look like a very, very large number, but it's not denominated in Ether. It's denominated in the lowest unit, which is the Wei. And in fact, conveniently, Etherscan provides us with a link that we can click on, and we can see that this large number of Wei, if we scroll all the way down, turns out to be 0.001 Ether. And that's about $1 or $2. So anyway, let's go back to the functions. Scrolling down, there's a bunch where initially you may think, well, what is that about? What is castle level. What is castle price? There are some, however, that will be familiar to people who've looked at NFT contracts. For example, there's a URI function here. And in an NFT contract, when you call the URI function with a token ID, and I'll just stick a random token ID in there. I can do this for the Authorverse because every single token ID exists. If you're going to a normal NFT contract, say there were 10,000 tokens, you should be picking a number between 1 and 10,000. And we can then query it, and we get back a URL. And this points to where the metadata for this particular token that I just typed in can be found. So I'll copy that, and I'll just quickly go and show you what happens when we visit that. Okay, we follow that link, and this is a metadata file for an NFT. It's stored off the chain. In fact, it's stored in authorverse.io API metadata and then this file name here. And this gives us the details for the particular token that I was looking at. It's the Authorverse land of Ardeanica. Here's a link to the image that represents it, and we'll look at that in a short moment. And we can see all the traits that it has, and we can see here that it has something called a castle level of 0. So I'll now follow the link from the metadata, which remember we got to using a link from the actual NFT contract. And if we follow that link, we should be able to see what Ardeanica looks like. And the answer is it looks like this. So, oh, that's fun. We've pursued the contract through to the metadata and the image. Now let's go back to the contract again. So we can then start looking at some of these other readable functions. For example, royalty info tells me that the contract contains a function that implements a standard to allow NFT marketplaces to determine what royalties should be paid and who it should be paid to. So we'll go back down and grab that token ID, and we'll say here, imagine that we are buying that token for the princely sum of 100 ETH. And when we click this, it tells us that you should be paying 2 ETH to this address as a royalty. So there's 24 functions listed here. Some of them are more interesting than others, but it gives us an overview of the structure of the information that can be read from the contract. And let's have a click on one other one as well. So castle base price. So this is if you're going to level up an Authorverse token from a castle level of 0 to a castle level of 1, it's going to cost you this much. And that, we can click on the converter link again. It's 0.008 ETH to raise your token up one level. But how could we do that? Well, this is where we go to the third button here, the write contract page. And this shows us a list of all the different functions in the smart contract that we can transact with. Now, transactions are going to cost money, and that's why you need to connect to Web3. And there is this connect to Web3 button. I'm going to give it a shot. I'm not sure I'm logged into MetaMask or not. I am, and here we go. I'm connected via a Web3 connection to that address in my MetaMask wallet. And here it is, account 7 with the grand sum of $5.30 in Ether in it. And now I can go and look at some of these functions. So we can see here there's a flip realm function. Who knows what that does? Well, I do because I wrote it with Richard, but a programmer coming to this won't initially know, but at least it gives you some indication again of some of the structure and some of the things that there are in this contract. There's this gift function, something to do with a migrator, a standard function called renounce ownership that suggests that it's come from OpenZeppelin and it's using the ownable template, which means that eventually the owner of this contract can say, right, I now no longer own it. It's free out there on the blockchain and I don't have any influence over it anymore. We have the standard safe transfer and safe batch transfer functions for ERC1155 NFTs. So these are the functions that allow you to transfer a token from one address to another. And a few other functions here as well. So let's go to this upgrade castle level function. We click on that, and it says here that you have to specify how much you're going to pay in order to upgrade your castle and which tokens you want the castle to be upgraded for. So I could put in here that particular token I was looking at, and we had the price over here somewhere. Oh no, that was for flipping, wasn't it? It's this one. So we want this number. Copy, and I can feed it into the interface that Etherscan handily provides, and I could click write and do that, except I probably don't have enough money, or maybe this is not denominated in way. Let's have a look. No. Oh, it doesn't like the address value. There should probably be a 0x in front of that. No, okay, well, it's going wrong. Anyway, as I said, this is to explore the contract before you dive into the actual source code. So in a sense, this is actually a good learning experience. I've now got an indication that I don't really understand what parameters I'm supposed to be putting in here in order to get this upgrade castle level function to work. So let's go and have a look at the actual source code now. So now that we've got a feeling as to what functions can be read and what functions can be written, we can actually start looking through the individual source code. And we can see here, just as the read contract and the write contract listed the names of the functions, they're actually here. So for example, there's the function name, external pure returns, and it returns the string authorverse. And we can check that over here. Here is somewhere down here, there should be a name function. Here it is. Click. And indeed, it returns the value authorverse. Well, that's handy. And we can keep digging through the code. Let's see if I can find that write contract function we were looking at, upgrade castle level. Maybe I want to investigate that further. So we go to the code. I'll search for it, and there it is. There's something for the interface about it, but we're not seeing it in the actual source code. And that is because the source code for this contract is split into lots of different bits and bobs. And at this point, what I would do is I would copy paste all this code into an editor so that it's actually easier to work with. So I know what, maybe we should do that. I'm going to go and grab the ERC 1155 code from here. So I'm going to copy that, and I'm going to move a text editor over here, and I'm going to paste it in there. There it is. We have the source code, and now we can look for that upgrade. Is it found? Oh, upgrade is not found in that. Let's move along to the next function that I can copy. Not function, library that I can copy. Here we go. Call this up. Make a new document, paste it in. Find, and let's try upgrade again. There, function upgrade castle level. We found it. So it says here that it's payable, which means you need to send extra ether to it for it to work. It takes an address as an argument. It requires something called token castle level to not equal 7 or 15. So that's something we could investigate later if we want to learn more about it. It has something about addresses W0 and W1. And here we have the token castle level for token ID being upped. That's what that plus plus means. It means bump the value up by 1. So we just need to have an address and pay a fee. And I guess here is the problem. An address has a very specific length. And when I was interacting with the write contract, I didn't have enough characters. An address needs to start with 0x and be 40 characters long. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we are. That will make it a proper address. Looking at that, it didn't have any kind of adjustment for unit conversion, so it's going to be wanting the payment amount to be in way. So we'll stick that over here. And now when I click W, oh, not W, right, we shouldn't get an error anymore. It should actually give me the option of sending a transaction to the blockchain to interact with this upgrade castle level function in the Authorverse NFT contract. Click, oh, and there we go. It's offering me a transaction to submit. Now, amusingly, you can see here that it is suggesting that the gas fee, just get rid of this so you can see that more clearly. It's suggesting here that the gas fee is some phenomenal number. 1, 2, 3, 4, 5, 6, 6 times 3, 18 zeros, 23 times 10 to the 18 ether in order to get this transaction through, which suggests that something has gone wrong. And the problem probably is that I'm not paying enough. There's this problem in the interaction between MetaMask and blockchain smart contracts that it doesn't handle the wrong payment amounts well. I bet you if I stick a couple of zeros on the end of this, it'll work out. So I've got to reject, come on MetaMask, I've got to reject this transaction. I obviously have insufficient funds to do that. And here you can see Etherscan confirms that I rejected it. Let's try with more. No, it's still offering this huge sum. Anyway, again, not something I expected. I think one of the problems is I don't have enough funds in my wallet for starters. And this is something that you will come across occasionally where the gas fee is just crazy. Now, admittedly, I've never seen one to the level of 2.3 times 10 to the 25 ETH being proposed. Normally when it messes up, it's because there's a revert statement in the function that you're calling that is going to get triggered, and MetaMask's gas estimation and then goes a bit haywire. And typically it says that it's going to cost you 100 or 200 ETH in order to execute it. And don't then click on accept if you happen to have 100 or 200 ETH in your wallet, because you will lose it. And the transaction will almost certainly fail. But I've never seen the number come out this big. But anyway, these are the kind of quirks that you'll find, and it's an indication that the field is still relatively new because the error checking isn't complete. We're finding errors all the time, and different developers, when they have time, then try to fix them, or rather give you sensible error messages that something is going to go wrong, rather than stating that you should be spending 8 quintillion or quadrillion ETH on your transaction. Anyway, the whole idea of this was just to give you an indication of how I personally start exploring smart contracts, and hopefully it's a technique that you can use too. We'll just go back and have a look at the code a little bit more. So I had it open in the editor. So you see, this allows you to drill down into functions from a top level into a sort of more detailed level. Here's another one. There's a function called withdraw, and we can have a look at that. Function withdraw is an external function. It sets the variable balance equal to the amount of ether that the contract owns. It checks to see whether that balance is greater than 0, and if it isn't, the withdraw function bails, saying no funds. Otherwise, it calculates what half of the balance of the contract is. Balance times 5 divided by 10, well, that is the equivalent of balance times a half. This particular funny construct is used in Solidity because Solidity doesn't have decimal places. It has integer arithmetic, and so you have to kind of get around it by, when you're wanting to split an integer into 2, multiply it by a big number divided by an even bigger number, keeps it all in the integer range, and we will end up with roughly half of the value. And then it sends half to this W0 address and half to this W1 address. And we can actually go and check that in the contract. Here, read contract. I saw those earlier. Here's W0, it's an address. And here's W1, it's also an address. And each of those get half the money that the contract raises. And here's the withdraw function. Oh no, it's not going to be in the read, it's going to be in the write, because you're writing some information to the contract. What you're doing in this particular case is you're writing a transaction to the blockchain, telling the contract to do something, namely send funds around. And again, we can click that one and see what happens. Once again, oh no, this is the old one that I failed to reject. So yeah, you can see here it is, got cancelled. Let's try this. Up. There, we got a more sensible gas estimate. So it would cost me $8.32 to call that function and send the assets of the Authorverse NFT contract to those two addresses, which have been labeled W0 and W1. I have insufficient funds to do that. And in any case, why would I want to spend money to get this contract to transfer its assets out to those two addresses? But anyway, the whole idea of this was just to give you a lightning tour of the kind of things that you can do in order to investigate smart contracts, and to allow you to sort of dip your toe in, and then rather than getting overwhelmed by a massive smart contract or a constellation of smart contracts, you can get a sense of what's going on from this Etherscan page, and then dig down into the individual function and investigate them one by one if you want to cover the whole contract, or just look at particular ones that you're interested in. I've gone on a bit longer than I intended to. That's because this is a topic that I'm enthusiastic about and enjoy, and so maybe I got a bit overexcited. But I'm going to wrap this up now. I hope it's been useful for you guys, and I'll see you all in the next video soon. Bye for now.